everyone. Today we are going to learn about a very interesting tool used in coordinate geometry, that is homogenization of second degree curve. Before we jump into homogenization, let us look at this very interesting question. It says, what is the equation of pair of straight lines joining origin to points of intersection of a second degree curve and a straight line? That means we are given a second degree curve and a straight line and they are intersecting at 2 points. Now we have to find equation of pair of straight lines, right? Pair of straight lines that is joining origin and these points of intersection. So these are our points of intersection, and we have to find equation of pair of lines that are joining the origin and the point of intersection of these two curves. So we have to find the pair of equation of lines, and those lines are OA and OB, as you can see very well. Now, what is the equation of these two curves and lines? Say I give you general equation of second degree, that is this, and then general equation of a line, that is this. Now how will you proceed? Now you are told that you have to find equation of pair of straight lines. So how are you going to proceed in this question? Now you see, to find equation of pair of straight lines, you will first find equation of straight lines itself, and to find equation of straight lines you need to determine these points. So what will your mental thought would be? What's the process you're going to follow? Obviously you're going to find the points of intersection, that is A and B, and then you're going to find equation of OA and OB, and then you will proceed to find equation of pair of OA and OB. Wow, that's a long process, right? But what if I told you I have a key? By that you can directly jump from here to here. No need to do these two steps. Wow, wouldn't that be amazing? Now see, if you go to the market and you need ketchup for your burger, right? What would you do? Would you go buy some tomatoes and make ketchup at home, or just simply buy the ketchup? Which one would be easier? Of course, buying the ketchup directly, right? So instead of doing all these 3 steps, we will do a shorter step. That is, we directly buy the ketchup instead of doing all the hard work, and we get the same result. And what is that ketchup? What is that the direct method is called here? That direct method is called homogenization. That is our topic for today. What is homogenization and why do we need to do it? Right? Now, if you ask me the shortest answer to this question, I will say to save time. Isn't it? That's why we are buying the ketchup, right? Now the question is, when do we need to homogenize? When is the question here, right? You see, we have curve C, we have line L, and let's say I give them L1 and L2 name. Okay. Now, when I need to find pair of equation of straight lines OA and OB, right? Then we use the concept of homogenization. I will be given such setup where there's curve and there's line, they are intersecting each other at 2 points, and we have to find equation of lines L1 and L2, or we have to find a pair of equation of those lines. We use the concept of homogenization. Now, is it just limited to this? No, it is not limited to this. You see, when you are doing a question, it will not be given to you that you have to do the homogenization process. You have to think through it. That is the process of homogenization applicable here? How will you think about it? How will you come to know that this is the right time to do homogenization, or this question requires the process of homogenization? So you see, there you will be given a setup of a curve, a line, and the pair of lines that will be intersecting their intersection, right? That will be joining intersection and the origin. such case will be given to you, and information about any two out of them. You see, any two out of them. Like in this case, the question that we were assuming, we are given equation of curve, we are given equation of line, but we have to find pair of equation of L1 and L2. So we applied homogenization. See, you see, if instead information about L1, L2 and L is given, we can find equation of curve. We can find whatever you need about the curve. If we have the equation, we know everything about the curve, right? Similarly, if equation of curve is given and information about L1, L2 is given, we can easily find what's L and what's the equation, what kind of line it is, from where it is passing. So it is super easy process, right? You just need to know two out of these three things and you can easily know the third thing, right? So we can say that also you can find angle between the lines L1 and L2, and with this you can find equation of the straight line, as I said, the equation of L. So very easy, right? You will easily be able to spot that this question needs homogenization or not. You just have to check these three things. We'll do more questions in this and you will get a clear idea of this. Now the question is, what is homogenization? We've been talking about homogenization for long. So what does it mean? What do we have to do in this? These are the questions in your mind. So first of all, let's understand the meaning of homogeneous. Homo means same and genus means kind. So those things that are made up of same kind of parts are called homogeneous. Very simple. But when we talk about it in mathematics, we have homogeneous equations, and how to identify homogeneous equation is the question here. You see, when all the terms of equation are of same degree. For example, you see degree of this term is 7 because 5 plus 2 7, and here 1 plus 6 7. So we can simply call it homogeneous equation of 7 degree, right? Now this is homogeneous equation. Now what is homogenization? What do we mean by homogenization? What's the meaning of it? So homogenization means the process of making homogeneous. The process of making homogeneous. Obviously, if you have to make something homogeneous, what type of it should be? It would be a non-homogeneous thing. You convert a non-homogeneous to homogeneous, and this process is called homogenization. You see, let's take the example again. We have equation of curve, we have equation of line. Okay, so this is our diagram. Now, how do we apply the process of homogenization here? You see, this clearly, this is a non-homogeneous equation. How? You see, this degree 2, it has degree 2, it has degree 2, oh, it has degree 1, it has degree 1, and it has degree 0, right? Now this is a non-homogeneous equation. Now we convert this non-homogeneous equation into a homogeneous equation, and that process is homogenization, and finally we get a homogeneous equation of this type. And this is nothing but equation of pair of straight line passing through origin. So what we did is, we had this non-homogeneous equation, we homogenized it, we converted it into a homogeneous equation, and we got equation of pair of straight lines passing through origin, and that will be the equation of OA and OP respectively. Right? Now this is the whole procedure of homogenization. Why are we doing homogenization? To simplify the method of solving and to find equation of pair of OA and OB lines. And how do we do it? We homogenize the non-homogeneous equation of the curve and we get the homogeneous equation. Suppose the equation of curve is given as this: ax square plus 2hxy plus by square plus 2fx plus 2gy plus c equal to 0. This is our non-homogeneous equation, right? And this is our equation of straight line intersecting this curve and that is intersecting the curve at 2 points as we saw in the figure. Now what will be our step 1? A step 1 is to find value of 1 using equation 2. So what do we do is here, we take the n on the right side and then we divide it by minus n and then we get the value of 1. Why do we do this? To homogenize equation number 1. And let's see how do we proceed. We rewrite equation number 1 as this. It's the same equation. It's of degree 2. It was of degree 2, and it was of degree 1, and degree 0. Right? Now we multiply here 1 time. We multiply here again 1 time and here 2 times. Because here the degree is 0. So in order to make that degree 2, we multiply 1 by 1 2 times. That is square of 1. Now what was the value of 1 that we found out from the equation 2? This was from equation 2 and this is from equation number 1. Now we use use value of 1 into the equation number 1. We get this. You see what did I do here? I put value of 1 here and then this and then this. After solving it, I got this kind of equation. You see, isn't that a homogeneous equation? Coefficient x square, xy, y square. All the terms with coefficient x, y or 0 are vanished. The constant term are vanished. All left is just an homogeneous equation. And what do I do is here, I replace it by a, I replace it by h, I replace it by b. So what do I get here? This equation. And this equation is nothing but represents equation of pair of straight lines that is passing through the origin. You see, this is homogeneous equation of second order and this is our figure. And what do we know here? That this equation represents equation of pair of straight lines passing through origin. And we also know that we have derived this equation using equation of line and curve. So it must satisfy the condition of the intersection, because we have found out this equation by solving these two equations. So it must satisfy L and C, as well as it represents equation of straight line passing through equation of pair of straight line passing through origin. So those lines must be these L1 and L2, isn't it? Right. So that means the equation that we have just found out is the equation of pair of L1 and L2, and that's what we wanted to find. So that's how we homogenized the given non-homogeneous equation and we found a homogeneous equation, and hence we found the equation of pair of straight lines L1 and L2. Alright. Now let's do a question on this. Okay. So question is, find the joint equation of the straight lines passing through the origin O and the points of intersections of the line this and the curve this. That means equation of curve is given as this, and if you draw it you will get an ellipse. Okay, and this is the equation of line, and if you will draw this line, if you plot this on plot it on this graph, you will get this. Okay, so what do we have to find? We have to find joint equation of straight lines passing through origin and the point of intersection. So these are the point of intersection A and B here. Okay, and what do we have to find? Lines joining OA and OB. So we have to find joint equation of OA and OB. So definitely we can tell that the method of homogenization is going to be applied here, right? So let's see. This is our diagram, and we write equation of curve and we write equation of line. So what was our first step? Our first step was to calculate value of 1 using equation number 2. Okay, so we will calculate value of 1. You see here this 3x y plus 4y equals to 5, and then the 5 comes into the denominator, you will get this value of 1. Fine. Now you will see equation of curve. Now what do we do is we put this value of 1 into equation of curve. And how do we do it? We rewrite the equation here. We multiply the constant term with 1 square, and there are no x and y terms, so we don't need to do anything with that, right? So what do we do here is we multiply it by 1 square, we put the value of 1 in this, and that's the homogeneous equation we get. Okay, now this second order homogeneous, what does it represents? It represents this OA and OB. That means it is the joint equation of OA and OB. So that simple it is. You did it in just 2 steps, and it took only 1 page instead of 2 or 3. See, so how easy this method makes calculation, right? So let's see what we did. We took equation of curve, we took equation of line, we calculate a value of 1, we put it into the equation of curve, and we got the homogeneous equation, right? Let us do one more question on this. What variety can we see here, right? See, find the general equation of chords of the curve. This is the curve, and you have to find general equation of the chord. Now what does this equation represents? If you know, then this equation represents an ellipse. Okay, now with subtend right angle at the origin. That means this is the curve, and chord of this curve, you see curve will look like this. Okay, now chord of this curve, let's say this is the chord. Now this chord is such that it subtends the right angle at the origin. It is necessary. The angle should be right angle. That means these are the lines intersecting OA, passing from OA and OB, and these lines are perpendicular to each other. So such chords of this ellipse, okay, there will be many chords like this. This is not the only example. If you rotate it, this chord, you will get multiple chords that make 90-degree angle with the origin. Now, can we apply the method of homogenization here? Definitely we can. You see, we have information about the curve. We know the equation of curve. We have information about the L1 and L2. And what do we have to find here? We have to find L, right? So that's very easy. Now how will we apply the process of homogenization here? That's the question. You know, what do? We write equation of curve. This is the equation of curve. And then we write equation of line, but we don't know the equation of line here, right? So we will take the general equation of line, that is y equals to mx plus c. Alright, now how to proceed? What do? We find value of 1 using equation number 2. Okay, so we found value of equation number 1 using 2. You can do it, right? Now what do? We will multiply it by 1 and put this value of 1 into this. This is our next step. So what did I do here? I rewrite the equation of curve here. I put the value of 1 into this, and I solved this. This is the final equation that I got. Now what does this equation represents? This is a homogeneous equation. And what does this homogeneous equation represents? It represents joint equation of OA and OB. Alright. Now this, and we know it is given in the question that these OA and OB make right angle with the origin. Okay, these make right angle with the origin. So if we know the joint equation of OA and OB, and we know that they are perpendicular to each other, now this is the condition of perpendicular lines. What is A and B here? A is the coefficient of x square, B is the coefficient of y square. Alright, now if we add them, now this condition come from the formula that tan theta is equal to the angle formula that you know of a pair of straight lines. Same formula is applied here, right? From that we get that the a plus b was in denominator, so if it becomes 0, so tan theta equal to 0, that means perpendicular lines, right? So what do we have here? We get c equal to minus m when we do it like this. 2 plus 5m by c plus 3 equal to 0. When you solve this, you will get c equal to minus m. Now what do we do with this c equal to minus m? We go back to the beginning. What was the initial equation of straight line that we assumed of L? Y equal to mx plus c. This was the equation that we assumed, that L is this. Now what do we do here? We put c equal to minus m here, and this is the equation that we got. Now this is the general equation which will vary along with m. If you know m, and what is m? M is the slope of chord. Now this is the general equation of chord, m is the slope. If you know the slope, you can definitely get equation of that particular chord. Alright, so you see what was given here. Information about c was given, information about L1 and L2 was given, and we had to find information about L. So this method can be applied anywhere, as I told you before, where two things are known and we have to find the third thing. Alright, now see this question. Here you have to find angle between those lines, and equation of curve is given, equation of line is given. Try it yourself, and I'm sure you will definitely be able to do this. Alright, now the question comes, what else can be done using homogenization? We have studied that if we know three things, we can find that if we know two things, we can find the third thing, and we have applied it to only second degree curves. But is it more? Is there more? Yes, there is definitely more. You see, homogenization can be applied to any curve of any degree. Here we only applied it to second degree curves, but it can be applied to higher degree, third degree, fourth degree, any degree. Okay, that requires complex calculation, but yes, it is possible. Second point is, it can also be used in the case of intersection of two curves. What does that mean? See, all the cases that we did here were like there is a curve and then there's a line intersecting it, and then we used to find equation of these two lines, right? But if it's a case of two curves like this, you can again use this homogenization method to solve this problem. See, what does homogenization means? Homogenization means making equation of a non-homogeneous equation homogeneous, and you can take any of the curve and make its equation homogeneous with the help of second curve, and then you get the homogeneous equation which represents pair of equation of these two lines. So it is not necessary that you follow the rigid method that you have been taught. Okay, you just have to find a way to make equation of the curve homogeneous, and you get the equation of joint equation of straight lines, right? Now next is, not just in coordinate geometry, it has wide applications in differential equations. Yes, definitely, it's not limited to this, it goes further. Okay, if you study higher mathematics, you will see its application. All right, thank you, that's all for today. I hope you got the clear idea of what homogenization is and when do we need it, and try solving more problems. All the best. Thank you.